Homework number 5, problem number 10. We're going to solve an equation in this problem. The equation is 4x squared equals 12. Okay? 4x squared equals 12. Now let's think about this logically before we begin. It says in English, 4 times some number squared equals 12. Well, we can begin solving this like any equation. We're trying to get x alone. So what's stuck to x? The 4. How's it stuck there? Well, there's an invisible times sign. How do I undo multiplication? I divide. In algebra, we use a fraction bar for division. What I do to one side, I always must do exactly the same thing to the other side. Keep things balanced. And so now over here, 4 divided by 4 is just 1x squared. We're too lazy to write the 1, so we just write x squared. We almost have x alone, but not quite. On the other side, we have 12 divided by 4, and that is, of course, 3. Now, when I say we don't have x alone yet, it's because this is x times itself, x squared. We need to undo that, so we just have x. And the operation that undoes squaring is square rooting. So I'm going to be taking the square root of each side of this equation. I'm going to rewrite it first so I can track my progress here. Again, the operation that undoes squaring is square rooting. And what I do to one side, I must do to the other side. There's one more thing we need to think about, but I'm going to interject for a moment and have you look at your calculator. On my calculator, the squaring key, let me see if I can get that to focus. It's a little unfocused. This is my x squared key. It's a little hard to see. And above that is my square root sign in yellow. Again, that reinforces the fact that this key undoes that. These two undo each other. They're inverse operations. Right, but the thing that we have to be aware of is, let's say I had a simpler equation, x squared equals 16, for instance. And again, this is asking you what number times itself makes 16. Now most of you would immediately say 4. 4 times 4 equals 16. So x must be 4. But there's another answer. Think about it. What about negative 4 times itself? Doesn't that also make a positive 16? So x actually has two possibilities. The positive one and the negative one. So back to this, when we take the square root of both sides of an equation, we have to realize that x squared could, the square root of x could possibly be a positive answer or a negative answer. So there's always two steps to taking the square root. And that second step is to write this in front of the square root sign, plus or minus. Let me write that again so it's a little bit clearer. When taking the square root of both sides of an equation, be sure to write plus and minus in front of the side of the equation that doesn't involve the variable in this case. So now the squaring and the square rooting undo each other and x falls out. Just plain old x. And over here I can write my answer two different ways. I can leave it in radical form, that's what this is called with the square root sign on it, or depending upon what the problem asks for, I can find the answer to the square root of 3, the approximate answer that is, by using my square root key. And let's see, did they tell us what to round to in this case? It looks like the answer was rounded to the nearest thousandths, so 1.732. And again, it has to be a positive 1.732 and a negative 1.732. Both answers are possible. Now, mathematicians are lazy, so lots of times they'll just go like this, as I did back here for the square root answer. They'll just write the answer once. Oops, don't want the square root sign there, sorry. Ooh, that's a common mistake. I'm almost glad I made that mistake. The answer is just the number, not the square root of, but the number, positive 1 in 737 thousandths or negative 137, I can't say it, 1.732. So again, careful. We don't need the square root sign anymore because we already took the square root to get this decimal answer.